Yes, good afternoon, everybody. Just let me know if my voice is clear and you're able to see the
Yes,
screen.
sir.
Thanks, Abhishek. And is the screen also visible?
Yes.
Yes, sir. Yes, sir.
Okay. Yeah. So just let me know if anywhere you face voice lagging or something, because I'm using some alternate source for internet, so it's not very stable. But let's begin now. I believe most of you have joined, and if you have any kind of query, any questions you have, you can either just unmute yourself and ask, or you can put it in the chat box, or you can just raise your hand and we can discuss. So is it good to start, Tripti ma'am? Is it good to start? Probably she's not able to hear. Okay. Yeah, so yeah, some people have already started working on my screen, so let me just help you. Okay, fine. Hmm. All right. Once again, let me just thank Tripti ma'am for giving this opportunity to have interaction with you, and any one of you can introduce yourself as a group. What exactly level you have now? Okay, you are in third year, I believe, right?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, and all from computers.
Yes, sir.
Okay,
Yes, sir.
all right, fine. Thank you. So I'm Kushal. I have been into analytics for more than now 7 years, and I if you want to know about myself, you can go to LinkedIn, and my ID is Kushal Sharma 76. So Kushal Sharma 76, you can search and you can know more about me. I have two startups here in Pune, and I have been working with many companies. You can mute yourself till the time there is no requirement to interact. Pratiksha, you can mute yourself, right? Yeah, let me mute her. Okay. So I have been working with multiple companies for training purpose or for consulting purpose. Okay. Yes, Sakshi, do you have something to say? So I request everybody to mute yourself. Okay, I have muted. Fine. I think this. Okay. Shall I remove the permission? I believe you guys are mature enough. Okay. All right. So today's webinar, it is about data science and data science with R. Okay. So we'll just have an intro. Is my voice not coming? I got a message. Is it not coming?
It is audible.
It is audible.
Audible, sir.
Okay. Okay. Let me just answer to. All right. So let's continue. Yes. So data science with R. Now, um, this will be the flow of the discussion: data, big data, data science, data mining. Okay, so many things we have in today's era. Okay, so we'll be discussing all about them. It's introductory, completely introductory level webinar. Okay, so don't expect, okay, so going much deeper into, but yes, you can ask whatever query you have. You may surely ask them. I'll be happy to answer. Okay, so let's begin with the data itself. Okay, so you can see in the slide, what is data? This is a definition which we must have read in our school times, maybe in 8th standard or 7th standard, maybe probably below that. Okay, so data is raw facts and figures. That is, we call it as data. Okay. And further moving, this data becomes information when we process it. Okay, so we call it as processed data becomes information. Okay, and information is useful. Raw data is having potential use, but if you process it, it becomes information, and which is very useful. Okay, Here you can see very quickly that we have so many different formats of data. We can have audio visuals, okay, we can have text data, we can have data from different sources like IoT devices, from sensors, okay. So these are different sources or formats of data we have been facing today. And this is something which each and every individual is a part of data generation as well as data consumption. Okay, we all are a part of this data generating, processing, and consumption, and we all are getting affected every day by the different kind of data which is being generated. But now the question is why this data became big data. So here I would like to invite some, from you guys, that why this data do you think became big data? Some quick responses. Yeah, let us keep it very interactive. Yes, why this data became big data? So be attentive and be, keep on responding. Yes, anybody? Abhishek, Aishwarya, Alija, Anil. Okay, so, yes, Ratan.
Because it privacy is means some personal data, so it the big.
First, I didn't exactly, I did not get convinced. Okay, and any other, some, please add up more things. Okay, once you add more things, it will become more relevant. Yes, Arjun. All right, fine. So let's continue. If there are no responses, we'll continue. Okay. Even in chat box. Okay. No. Okay. Organizations can improve their services based on user data, such as what they like, search. Okay, Swapnil. Yes. So that is, yes. Organization can improve. That is true. But we are talking about how data became big. Okay. Why this big word got attached to data? Okay, that is the question we are discussing. Okay, so let us continue the discussion. Okay, now let me take you to the next slide. These are the reasons, and I know that you are aware. You must have read about, okay, these v's. Okay, volume, velocity, variety, veracity, value, and variability. These are the famous v's which actually makes data as big data. Okay, let us quickly, one by one, have a look at these things. And once again, I'm saying be very, open for the discussion, so that it remains very interactive. Okay, so it will be useful. Okay, in this slide, you can see that what is the meaning of all these components. Okay, so yes, so here you can see volume. Okay, so volume is the amount of data from myriad sources. Give me example. Where do you see the volume? Quickly, give me example.
Social media.
Social media. Arjun, you can have a word with us. We are hearing some other noise from your side. Yeah, social media. Other answers. We have around 100 people here.
So the
Yeah, please.
vastly increasing e-commerce.
I think I did not get the voice properly. I missed.
Hello, sir.
Hello, sir. Search engine, maybe.
Yeah, search engine. Yeah, true, correct. Search engine. Video streaming services. Yes, Swapnil. Hmm. Mac, can you please rename yourself so that I can, interact with you with your name? Okay, fine. So volume basically means wherever you see that data is stored. Okay, so simple terms, you can call them as data centers. Okay, we have different data centers. So data centers are example of volume. Okay, so let's say we have a bank data. Okay, bank has got a data center. So all that data basically is stored there, that contributes to the volume. Somebody said search engines. Yes, obviously search engine, they keep on doing storing lot of. Okay, Shubham, you can rename yourself. Okay. All right. So banks are there. Okay. Search engine, yes, they store a lot of data. Then social media, yes, every moment enormous amount of e-commerce industry, enormous amount of data is being created. Okay, so where this data is going, it is going to some data centers. Okay, so that means some servers are there. Okay, some servers are there, all that data is getting stored in the servers. Okay, so this is the volume part. Next is variety. Okay, so types of data, major classes, structured, semi-structured, unstructured. These are the major classes of data today we have. Okay, quickly, again, quick interaction. Tell me some example of structured, another semi-structured, and some example for unstructured. Okay, so out of 94 people, quick responses I expect. Yes. Apurva, Pingle, Arjun, Atharva, quick answers.
Yes, sir, the relational databases can be.
Yes, so RDBMS, that is structured. Okay. Yes, structured data. Semi-structured and unstructured. Silence. Yes, Aman.
For unstructured data, documents collection like invoices, records, emails.
Yes, correct. Yeah.
For semi-structured, it could be medical records.
Can you tell the structure? How is the medical record stored?
Maybe like for it, there is, so it's not exactly structured, but there is some semi-structured like way of storage. Maybe.
Semi-structure example is XML, CSV.
Yes, correct. Yeah. So what you both said is correct. Okay, you gave direct examples, and the other person said something which is not in a tabular format, but it has got some pattern. Okay, that's true. So wherever you are able to identify a pattern,
Sir, emails.
yes, there can be a debate on it. Okay, we can have a debate also for data to categorize it as semi-structured or unstructured. Okay, so if you are able to identify pattern, you can put it under semi-structured. Okay, whatever pattern. The normally the pattern is most of the standard patterns are like key value, key value. XML is also like that only. Okay, so property tag and property value, property tag and property value. Okay, so some kind of structure. Then you have log files. Log files, all the records you will find same structure. No, you will not find different structure on the data which is coming from logs. Okay, so wherever you are able to find some pattern, that is semi-structured data. All right, so let us go ahead now, and then we have velocity. Okay, I may not need not to explain velocity. Okay, the speed, the frequency at which the data is being created today. And we all know that all the devices today are data generation devices. Okay, whether we talk about mobile phone, whether we talk about let's say you have devices like Alexa, you have devices like cameras and sensors on all the streets today in the smart cities. Okay, in hospital buildings, in shopping malls. So all these are small examples which are basically helping us out to capture data every second in enormous amount. Okay, social media is big. Okay, we all know about it. So that is velocity, speed at which data is being generated. Even at this particular moment, if we look at our mobile is having more than 3 4 social media applications where we connect socially, or professional social networks are there, and each of those platforms are generating data. So even for me, I'll see by the end of the day, I may be able to see the data which is being generated, which is related to me, maybe coming in. Okay, maybe around 1 GB or more. Okay, just related to me. So similar way we can see millions of people are there. So how much, okay, GBs of data, or then it goes to terabytes and petabytes is being produced. Okay, then veracity. Yeah, so volume, variety, and velocity, these were the basic and given by a company called as Gartner. So Gartner gave these terminologies. Okay, then veracity came. So veracity is basically the degree to which big data can be trusted. Okay, so what does this mean? The degree to which big data can be trusted. So there could be some kind of ambiguity in the data itself. Okay, that may happen. It may happen due to the source from where the data is being okay captured, or it may be because of the maybe some missing values in the data. Okay, so due to some reason the data may get corrupted. Okay, so in that case, whether we can trust on the data or not. Okay, so that is called as veracity. Then next is value. Okay, value means, let's say, this is election time and we know that yes, people are voting for party A or party B. So let's say there are 50 people who support party A, 50 people support party B. Okay, so both the parties have got 50 people, okay, supporting. But on the day of voting day, 48 turned out for party A and only 34 turned out for party B. Okay, rest of them, they didn't go for voting. What will happen? So we were able to capture less amount of data and the results are ambiguous. Okay, otherwise there could have been very competitive results and we may have to do the re-election. Okay, so you can see that the more data you will be able to collect, the better results, okay, the precise results you will be able to get. Okay, in actual 50 people support A and 50 people support B, but while collecting data, capturing data, only 48 were able to vote out of 50 for A and 34 out of 50 for B. Okay, so we are not able to collect all the data. So that shows us value. Okay, even in some experiments, if you see, we try to have data as much as possible after the decimal values also. Okay, why? Because let's say you are planning to go to moon and you yourself are calculating everything. Okay, so you have done everything and you just need to calculate the degree at which okay you need to start from earth. Okay, so this particular angle is something which is very important. This particular angle is very important. Okay, so you would like to be very precise. Okay, whatever angle you need to take, so you would like to take as much as values possible after the decimal also, so that you land up on the moon. Okay, otherwise you may land up on some star. Okay, which you probably would not like. So again, this is also an example of data. Okay, more the number of values you are keeping, that means you are increasing the length of that particular variable. Okay, and ultimately if you have to store such records, so it will probably consume more storage. Okay, so more the data, it will be creating more value. Okay, better will be the precision, better will be the result. Variability comes. Variability is the ways in which big data can be used and formatted. Okay, so this is basically where you can apply the big data analysis. Okay, so you have data now, and that data can be used in different, maybe you can say, domains. Okay, like you have in a particular organization, you have HR domain, you have a sales and business development domain, you have marketing domain, you have a technical support domain, you have some customer service domain. So many domains are there, and each domain is having processes, and your data can be applied to improve these domains and the processes in the domains. That is called as variability. Okay, so these are the 6 V's. Anything you want to ask about these 6 V's? I know you must have read about them, you must have discussed about them, but still, if you have something, you can ask me directly or on the chat. Yeah, I give you 5 seconds, you can ask me. All right, so let's move ahead. If you have any question, as I said, you can always raise your hand and keep on asking me. Now, these are some example. Okay, a database, example of structured, okay, storage. You can see in the diagram itself, it's a tabular like okay structure, and the data which is stored in these kind of table formats. Okay, that is basically called as database. Okay, just write in the chat. Okay, some examples of database. Okay, while I'm going ahead, you can just write in the chat some examples of database which you have used or you have just read about. Okay, then a database, and another we have is file system. Okay, so either we store our data very organized way in a database, or we store our data. Okay, you can see the heaps here. Okay, or stacks, you can uh, okay, so these are not heaps, these are stacks. Okay, one on top of the other. Okay, so you can see. Okay, so this is how we organize our data. Okay, in the file system. And they're very similar to lockers, almirahs, and cupboards. Okay, and structured data is something like this. Okay, you have tabular format, and this is how you store your data. Okay, fine. I asked you to write the names of the database in the chat box. I have not received any. Okay, what does that mean? That 89 people are not listening? So I think you should write here. Yeah, please keep following with me. Thank you, Shruti. So MySQL is one of the very common example. Now related to, yes, Apurva, MySQL, Oracle, RDBMS, yes, correct. Yeah. So there are two primary purpose of these database softwares. One is OLTP, another is OLAP. Okay, OLAP. So I would like to have somebody, okay, out of you to quickly discuss about these two terminologies. Yeah, who would like to come up and discuss? Yes, Priyanshu, would you like to discuss? Ashwarya, Aman? Okay, no responses. Archit, would you like to discuss something? No, Athar?
Sir, is OLTP is a enterprise system.
Okay.
It
Okay.
is used in entry sales.
Yeah, that's right. That's right. Okay. Yeah, some more inputs I want. If you don't know, you should at least unmute yourself and say, I don't know. I'll be more than happy to listen to your voice. Yes, Aman. Aman Tal Bhandare. Yes. Amritesh.
Yes, sir.
Yes. You're listening to me, right?
Yes, sir. Yeah.
Okay, thank you. So what do you understand? OLTP and OLAP? Yes, Aman, I'm asking you. Okay, no response. Yeah, if you will respond, I'll be more happy to listen and discuss. Okay, otherwise I'll keep on speaking. I have no problem. So OLTP, if you see, so online transaction processing. Okay, transaction processing. What do you understand by a transaction? Transaction. What is the meaning of a transaction?
Sending a money from one account to another account.
Okay, correct. Yeah, so in terms of a banking transaction, sending money from one account to another account. Okay, so that's called as a transaction. Okay, now as I asked question and Rahul responded. Okay, this is also called as a transaction. Okay, I asked it, so I initiated one transaction, and because Rahul heard it, so one transaction was over. Yes, Arjun, please continue. I didn't get your voice, Arjun. Okay, is my voice audible? Is anybody able to hear Arjun's voice?
No, sir.
Okay,
No, sir.
fine. Arjun, your voice is not audible. Fine. So examples for OLTP. So Abhishek already said some kind of enterprise systems. Yes. The simple example which we everyday use is your e-commerce industry. Okay, your e-commerce industry is completely OLTP based. Okay, why? Because every day you make some order, and your order is being processed. The status of the order is getting changed. So what is happening? These are nothing but transactions. Which transactions? Database transactions. Okay, so keep this very simple. Let's make it very simple. You have, yeah, Dhanashri says financial transactions. Yes, financial transactions. You are correct. Okay, just think about a database. Okay, because where these transactions are happening inside a database. Okay, the database is used in so many application domains. Okay, financial is only one domain. Okay, banking, finance, that is one domain. Okay, any system you think of, okay, your attendance system, very simple attendance system, what happens? Okay, that's a transactional system. Every day one transaction happens for you. Okay, whether you are present or absent, so that's one transaction. Okay, database entries, okay, or database changes are called as transactions. Okay, you add some row, that's a transaction. You change a row, that's a transaction. Okay, you place an order, that's a transaction. You cancel an order, that's another transaction. I believe transaction thing is very clear. Okay, so how these transactions are happening? They're happening real time. Understand this word, real time. Real time means just now we require to do something, a transaction takes place. Okay, so these are real time. Now, going further, we have another term as OLAP, online analytical processing. Okay, so again, quick, I want some response. Okay, what difference do you see in analytical processing and transaction processing? What difference do you see here?
OLAP is designed for processing analytic requirements.
Yeah, designed for processing analytical requirement. Okay, fine. So what do we process here? What do we process here?
The data of transactions.
Exactly, the data of transactions. Yeah, that's wonderful. Okay, it made very simple. Transactions, it's happening as of now also. Okay, it might be somebody is in very urgency, okay, of booking something, so you might have been using your Amazon, Flipkart, or some food panda or Swiggy or whatever. Okay, so you will book something. Okay, what happened? Transaction happened. But after a month's time, okay, let's say Swiggy is or Zomato. Okay, let's talk about Zomato. Zomato is trying to understand, yeah, what was the business this month for the Pune region. Okay, so they're trying to understand what was the business for Pune region in the past month. What they are doing, they're collecting all the transactions. Okay, so yes, so they are collecting all the transactions for the whole month, and what they are doing, they're trying to process it. Okay, so this transaction is for complete month. Okay, so that makes it different. That's make analytical processing different from transaction processing. So I believe this concept is simple and clear to you. If not, you can please once again ask me. Transaction, whatever is happening now. Okay, we are making some updates, entries, deletion, some kind of operations in the database. That is transaction. Okay, we are not directly logging into the MySQL or Oracle, but we are using some application, and that application is making at the backend. That is transaction. But what is OLAP? All those transactions in future, okay, will become history. All those transactions will become history. Okay, that historical data we are using now for analysis purpose, and that is basically called as online analytical processing. Okay, is it clear? Can you please give me quick, yes, 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 no, 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 so that I can
Yes,
get.
sir.
Thank you.
Yes,
Okay.
sir.
Yes, sir.
Yeah.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yeah,
Yes, sir.
you can put in
Yes,
chat
sir.
also. Yes, no, yes, no, you can put in chat. Okay, other things you can unmute and tell me. Thank you, thanks for confirming. Okay, so let's move ahead. Okay, now look at this diagram, data science. Okay, you can see the topic as well, data science, because that is something we need to discuss today. So data science. Okay, now again, I always look at the words. Okay, look at the word data, and the other word is science. Okay, so quickly tell me, we have already discussed data, so I need not to ask you about it. Okay, we have discussed in the first slide. What what how will you define science? What is science? Yes, quick. Science, we studied science, right? Social science, physics, chemistry, mathematics is also a science, biology is a science. What is a science? What is science? Yes, yes, quick responses. What is science? You can type and send me. What is science? All are engineers, right? Budding engineers. Okay, somebody says innovation. Okay, yes. Yeah, please keep on typing and sending it to me. Problem solving, practical activity, exploring insights, study of a particular way thing works. Yes, thank you, Pratik. Thank you, Rohit. Curiosity, Mehant, Apurva. Okay, thanks a lot. Okay, curiosity. Yes, study of natural laws. Laws. Okay, so many things you are saying. Okay, yes, that's true. Okay, so study can be the first thing. Study of. Okay, and I'll take the simple okay word, study of, studying through observations. Yes, correct. Okay, now let us understand. Okay, in with very simple way, let us understand study. Okay, if you study physical objects, Okay, you can broadly call it as you are studying physics of a particular entity. Okay, if you are studying the composition of that object, okay, the molecules, the electrons, protons, neutrons, or other particles, okay, you are getting into the chemistry, okay, chemistry of that particular element. Okay, so if you are studying physically, so it will be call it you can call it as physical science, chemical science, biological science. Okay, similar way we are talking about data, and that's why we call it as data science. I think this is simple enough to make analogy. Okay, let's not make it complex. We are studying data, we are exploring data, we are we are doing some experiments with data. So whatever we do with data by applying algorithms or by doing some EDA, all that activity will be actually called as coming under data science, all those activities. Okay, so let us quickly go ahead and go through some definitions. Okay, so if you think the speed is too fast, you can just let me know. Okay, because I think these are just concepts and you can easily understand them, and you must have been reading about them as well. Yeah, so data science is a multidisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data. Okay, so just look at the words, okay, because they are important. So you can see here multidisciplinary. Okay, so that means there are multiple disciplines or domains. So multidisciplinary field that uses what they use: scientific methods, processes, algorithms, and systems. So many things are there. Scientific methods are there, processes are there, algorithms are there, systems are there. And what is the purpose? The purpose is to extract knowledge and insights from the structured and unstructured data. Okay, so there are different types of data we already have discussed. Okay, so from different types of data, the objective is to extract knowledge and to extract insights. Okay, now let's have some examples. Multidisciplinary field. So here we can have healthcare, we can have finance. Okay, you have already been giving examples. We can have some HR domain. We can have manufacturing domain. So many domains we have. So this is multidisciplinary. Okay, scientific methods. Okay, so scientific methods could be coming from maybe your stats. Okay, they may be coming from some statistical experiments. Okay, processes. Processes might be established while doing experiments. Okay, processes may be: first you collect the data, then you clean the data, then you pre-process the data, then you process the data, then you visualize the data. So this becomes a process. Okay, so these processes may have developed over the time. Okay, so it uses some processes. Then algorithms. Okay, now your algorithms may come from your data mining techniques, your machine learning techniques, your deep learning techniques, or your AI techniques. So algorithm may come from all these areas. Okay, systems may be your softwares. Okay, systems may be your it may be coming from your big data software tools are there. It may be coming from there. Okay, they might be some data handling tools or NoSQL databases are there. Those systems may help you. Okay, so you can see that so many things. Okay, lot of domains, then processes, algorithms, systems. Okay, they all are getting included. So I believe it makes you very clear that what data science is. It's a very high level, all covering. Okay, it's like a rooftop. Okay, and under the rooftop there are so many things inside data science. All right. So another definition here, you can see data science is the field of study that combines domain expertise, programming skills, and knowledge of the math and statistics to extract meaningful insights from the data. Okay, so I'll not get into much details now. Okay, from the previous definition only, you can just make a analogy and comparison. Okay, so this is a domain that combines domain expertise. Domain expertise means multidisciplinary field. Okay, so a field expertise, somebody should have a domain expertise, or he should be SME, subject matter expert. Okay, second is programming skills. Okay, so that will come under, you can say, algorithms. Okay, programming skills, knowledge of maths, that is basically some scientific methods. Okay, and statistics to extract meaningful insights. So the previous and this definition, they are same only. In turn, these systems generate insight that analysts and business users translate into tangible business value. This is a definition from Data Robot. Now after data science, let's move ahead and quickly have a look at a little bit of history. Okay, so you see that 1763 Bayes theorem. Okay, Thomas Bayes, he actually came up with Bayes theorem. 1805 Adrian Marie Legendre and Carl Friedrich Gauss, they came up with regression analysis. 1936 dawn of computer age, Alan Turing, universal machine was evolved. 1943 Warren McCloch and Walter Pitts, they came up with neural networks. So if you see all these concepts, they have been coming from 1763 till 1943. Only four stages I have mentioned here. So if somebody says, is this new? No, nothing is new. The research have been there for so long. Okay, but why it is being so much talked about? Why is it being so much talked about? What do you think? Why these things are very much being discussed today?
Computing power has grown today.
Okay, compute. Yeah, that's true. That's true. Okay, let's make it very simple. Okay, because analytics is touching the lives of each and every individual on earth today. In 1763, 1805, 1936, and even up to 1943, analytics, machine learning, AI was not actually intervening the daily lives of people. Do you agree with me? Yes, no. On chat, not on, right? Yes. So I got one yes. Only single person agrees with me. Okay, two yes. Fine. So this is why it is happening. Okay, because it is touching the lives of each and every. Our mobiles are basically AI supported. The cameras are AI supported. So therefore, these things are getting implemented practically. Okay, let's move ahead. Now there is a concept called as data mining. Give me a minute. All right, so I'm back. Okay. Yes. So just confirm me. Audible? Is it audible?
Yes,
Yes?
sir.
Okay, thanks. Yeah,
Yes, sir, you're audible.
thank you. So whatever we are discussing, is it something you already know everything, or should we keep on discussing this way, or should I take it to certain depth? What do you want? Accordingly, I'll process. Should I go with the flow? More depth. Okay, thanks. Yes. So yes, let me very quickly introduce you to these terms, and then we will just discuss different types of algorithms which we have in. Okay, yes, thanks, I just wanted that. So I'll not ask you much things now. Okay, during these terminologies. Okay, I'll directly take you to the different types of learning algorithms we have. Okay. Yes. So under data science, we have data mining. Okay, it is a process of discovering patterns in large data sets involving methods and methods at intersection of machine learning, statistics, and database systems. So data mining is coming under data science only. And again, the primary purpose is discovering patterns in large data sets. That is the primary objective. Okay, and based upon those patterns, again, further, okay, that is basically further decision making is made. AI is coming under your data mining. Okay, so it is coming under your data mining, and John McCarthy, he coined this particular term, artificial intelligence. That time they had got a lot of terminologies like thinking machines, artificial intelligence, information processing. So lot of such things were coming into picture, but ultimately they basically came up with a single term that is called as AI, artificial intelligence. And artificial intelligence is coming, as I said, it is coming under data mining. It is a specialized branch, a subset, you can say. What is additional here in AI? Additional thing is that it is actually getting the mining algorithms are getting applied onto machines, and machines are automatically taking it over. Okay, so machines are able to execute those algorithms, or in simple terms, I'll say the algorithms are nothing but logics. Okay. Yes, Salu, you can mute yourself. Okay, thank you. So, so this is basically AI where the machine is getting the logic, and the machine is able to implement that logic in the real situation. Okay, and that is something we call it as human intelligence or logical thinking inside machine. Then, yeah, this is another definition from Merriam Webmaster, that it is simulation of intelligent behaviors in computer. That is called as AI. But after that, there was a requirement that if a machine is getting a logic, and that logic is getting implemented, but in new scenarios, that machine is responding the same way. For example, let's say if you say hi and somebody says hi, if you say bye again, the person says hi, so we'll say, is he dumb? Doesn't he know that when I'm saying bye, he should also say that bye bye, take care, good day? Okay, so that basically means that this is a learning capability. We need to respond to different situations in a different way. So you must guess it. Yes, so it is machine learning. So after AI, okay, AI has to be combined with machine learning, where your logic, okay, logic is not restricted to a limited set of rules, but those rules are getting updated. Those rules are getting updated. Okay, the set of actions you need to perform will be updated. So that is called as machine learning, and this basically came up with this. Yes. So American, this person, he basically came up with machine learning. Okay. Machine learning, it is an application of artificial intelligence, and that provides systems ability that automatically learn and improve from experience. Okay. So that is how machine learning is a step ahead than artificial intelligence, and all the applications which we have today, if they are AI based, that means they have machine learning incorporated into them. Then another term coined was deep learning. That is again a subset of machine learning. Deep learning is actually machine learning only, but it specifically deals with neural networks. Okay, the way our neurons, work. The same way this deep learning actually works. Okay, so these are the certain terminologies, okay, which are very popular in data science, or basically in the artificial intelligence or machine learning domains. And here you can see we have learning paradigms. We have five important learning paradigms here: supervised, ensemble, unsupervised, probabilistic, and reinforcement. Let us have a quick look at them. Okay, so yes, how much familiarity do you have, or you are familiar? You can tell me, like, with which one you are more familiar with out of these learning paradigms. Quick, on chat or on, you can unmute and tell me which paradigms you have more read about it, or you may have experimented with that particular. So yes, supervised and unsupervised, Pratik says. Mehan says supervised learning. Okay. Fine. Yeah, that is expected because it starts yeah, so Rishi says supervised. Yes, so because it starts with there only. Okay, the normal discussions we always start with supervised, therefore that is something you are aware. And supervised is something which moreover, it becomes a base for all other types of learning. Okay, so now let's start with supervised. Sometimes we get confused with the word supervised. Okay, why this word supervised is here? Okay, so that is sometimes confusing. Okay, so let's make it very clear. Why is it supervised? Okay, Let's say if I give you, okay, don't look at the definition now. Let's say if I give you 10 apples, okay, and I tell you that these are apples. So you have the apples in front of you, 10 apples kept in front of you, and you know that these are apples. Okay, you know that. If I give you a 11th piece, okay, and I ask you, what is this? Okay, so immediately you'll be able to identify what that particular thing is. Okay, let's say these are the apples I'm giving to you, and after giving these apples I gave you one more, okay, the same size, color, okay, thing. You'll immediately tell that it's also an apple. Okay, why? Because you were able to supervise. Okay, use the word here, supervise. You were able to supervise the previous apples, and I had already told you that this is an apple, this is also an apple, this is also an apple. So I told that all these are apples only. So from the previous data, you are aware that something which is a little circular in shape, red in color, okay, is an apple. Okay, so you are already aware of it. So therefore it is called a supervised approach. Okay, now whatever decisions you take, okay, or a human takes, so it is mostly, okay, it is mostly affected by some past experiences. So experience is nothing but you had some input, and based upon that input you basically had some experience. Okay, that experience is the output. So you already know, if I will let's say if I'm going to ride fast, the chances of getting meeting up with some accident is more if I'm going to ride faster than the given speed. Okay, so the chances of getting experience is high. How do you know this? Because you know the data, you see the news, you have seen some accidents in front of your eyes as well, so you know the data. Okay, so wherever you have the input and output, okay, riding fast is input, meeting an accident is the output. That is called as supervised learning. Okay, so here you can see that supervised learning is the machine learning task of learning a function that maps an input to an output. So function, here is some function is there. Okay, function means relationship. Okay, function is a relationship between what? Input and output. Okay, so based on example input output pairs, so already you have some data that says, okay, let's say the person was driving 10 kilometers per hour, another person 20 kilometers, another person 30, 40, 50, 60, 70, 80, 90, 100, 20, okay, 120. So you have data of people who are riding at these speeds, and then also you have a data that how many times those people have met accident. Okay, so you have input also, input is speed, and how many times they have met with accident, that also you have. So based upon the speed and based upon the output you have, that how many times, if some new data comes in, then you can basically read this input, refer to this input, and you can tell that approximately what I believe, as per the previous data available, you will meet with accident 0 times, 1 time, 2 time, 3 time. Okay, based upon the speed and out number of accident present with you in the previous data. Okay, this is example of supervised learning. The apples example you can see here, this is an apples example. So input data we have given to a machine has seen that red colored and some green color and one stick kind of thing is there. So this particular entity with so much of weight is called as an apple. And once you give basically a same entity with a little different color, then also the machine is going to say it is an apple, because most of the features are matching with the other apples. Okay, why? Because it knows that all these are apples, and therefore it is able to compare it with the features, and the label of these fruits is apple. So the machine is able to identify it as an apple. Okay, supervised learning example. In supervised learning, the function is displayed like this: y is equal to f of x. Okay, so output, it's an apple, it depends on f of x. X is nothing but set of features. Okay, x is your set of features. Features maybe its color, its weight, its size, its volume. So that all basically is set of features. So f of x is a function which is giving the output. Okay, fine. I have given some links also here. Once you will get the presentation, you can go and watch more on the topics. Fine. Now in supervise, you have two approaches. One is classification approach, another is regression approach. Again, in a quick chat, or you can unmute and tell me what have you read about classification and regression, and if you have read, then give me some example and explanation about that quickly. Yes. Okay, so no response. So I take it as uh, that you have not read about it. Okay, so this particular thing, okay, classification and regression, these come under supervised only. Let me help you with example. Okay, so classification means you have classes. Okay, classes means you can have head class or tail class in a coin. So whenever you are going to toss a coin, okay, multiple coins, either they will show you head or they will show you tail. You know that, okay, only two classes are there. Similar way, let's say now a COVID situation is going on. So a person may be COVID infected or may not be COVID infected. It's again a classification. You have two classes, infected, not infected. Okay, so two classes are there. So classification is we have fixed classes. But in case of regression, if you see regression, it is not classes, but it is continuous value. Okay, for example, I run with a speed of, let's say, 10 kilometers or 20 kilometers per hour. Okay, so I run with a speed of 21 kilometers per hour. But let's say Abhishek runs with 50 kilometers per hour, and Ashwarya runs with, let's say, 45 kilometers per hour. Okay, so people are running with okay, speed. And speed, we can see that for me it is 50, for somebody it is 80, for somebody it is 69, 70, 71. So we don't have fixed set of categories here or classes here. So this is continuous value we are facing. So wherever you have continuous values, or another example is how much marks will I obtain this exam. So in this exam, what will be my score? So scores are not also having categorical values. So scores are having continuous values. Somebody can get 40, somebody can get 41, 2, 3, 4, 5. So it's continuous. Okay, so I believe you understood. In case of marks only, the grading system is classification, A, B, C, D grade, and the continuous values, marks, are basically regression problem. Okay, so these both are examples of supervised learning. Then unsupervised learning. Okay, this is different. Unsupervised learning is completely different. If you think of the current scenario, okay, current scenario of COVID. So as soon as COVID came into existence, okay, that time none of the doctors were even aware about this particular COVID-19 virus. Okay, and they were treating all the patient based upon their supervised experience. Okay, but they found that the people are not they are not getting cured, rather they are dying. So more and more people were dying. So that means the cure they were providing was not sufficient. Even the doctors died who treated the patients, and then they found that this is serious and this is something which we have not experienced earlier. So we don't have the kind of inputs, the kind of features, the symptoms we are able to see. These are the inputs, the features we are able to see in the patients, and the kind of output, that is the person is dying. Okay, so this combination we have not seen earlier. So that means there is something new, and we need to check for it. So this was a situation which we will call it as unsupervised learning situation. Okay, for this particular disease. Okay, or we can say this was semi supervised, you can say, or unsupervised. Again, a question of debate. Okay, but just to make it understandable, I told you that this is one situation where unsupervised approach comes into picture. Another way, unsupervised. Okay, now we humans are very civilized, we are very organized, we have so many belief systems. But let's say you don't have any belief system. Okay, no belief system on the basis of caste, color, creed, religion, nothing. Okay, and now you have to basically make some categories, you have to make some groups. Then you will look, maybe you will look at the physical appearances, maybe you will look at the height, maybe you will look at how people talk, and then you will be trying to trying to categorize them. Okay, maybe you will be seeing that where somebody lives, and based upon that you will try to categorize them. So what you are doing, you don't have any prior knowledge. Okay, you are absolutely naive in case of any kind of human belief systems. So you will have your own intuitions. Okay, your own assumptions. Okay, the assumptions could be, yes, gender, male, female, you will categorize two categories. Okay, the assumption could be height, okay, tall and short. The assumption could be living in Pune, living in Ahmedabad. Okay, demographics. So how far each of them live. So this is an approach of unsupervised learning where we don't have any input output pairs given. We only have data, and all the data is input. No output is there. So we ourselves have to come up with the output. So that is called as unsupervised learning. Okay. Yes, so a priori algorithm is one very important algorithm in unsupervised learning, and this a priori algorithm, this is this is based on association rules, and this association is I believe I may be able to show you. Yes, yeah, here you can see. So you can look at here and you can see that this is Kamala, and Kamala is buying some vegetables, but you see that Kamala is keeping the potatoes and the onions together. Okay, why is she keeping potatoes and onion together? I need not to answer you. Those who go to market for buying vegetables, they know it well. Okay, because if somebody is buying potato, is also buying onion. Okay, so that's the reason she keeps. Okay, so you can see that human mind is so organized. Okay, so a priori runs in the mind of human. Human knows that if somebody buys potato, normally they buy onion as well. Okay, so this way, or they keep dhania in front because they know that dhania is something anybody can pick up and take it. Dhania, mirchi, these kind of things. Okay, so this is an example. I have given you a very typical example of a vegetable seller, and but this happens everywhere. Okay, you can open up your Amazon Prime, Netflix, or which one is that? Yeah, whatever platforms you are using. Okay, so you can see there a priori is being used there, association rules are used there. Okay, these are basically helping us for recommendation systems. So this is an unsupervised approach. Okay, example. Then we have ensemble learning. Okay, so now I would like to have some chat. Tell me about ensemble learning. What is your knowledge of ensemble learning? Or okay, let me open the definition also. Yeah, tell me, what do you understand by ensemble learning? We have discussed supervised and unsupervised. Yes, quickly. So we are 76 here. So out of 76, I would like to, 2 3 guys to quickly tell their understanding of what is ensemble. What do you mean understand by ensemble? You can just go to Google and search what is ensemble and tell me. Yes, Shivani, Saili, Saurav, anybody? Siddhant, Vikas, Yojna, Mrunmai, Nikhil, anybody? No response. I'm expecting some responses. No response in the chat as well. Okay, at least tell me, have you read about ensembles or ensemble learning earlier? Did you ever hear about it? In the chat, you can say yes, no, no, sir. Okay, no. All right, no worries. Okay, okay, all right. So many no's. Okay. So, were you able to get what is ensemble? What is the meaning of ensemble? Let me help you.
Saksham.
Okay, Saksham. Did you try translating it in Hindi? Okay, Saksham, fine, no worries. Okay, so ensemble, let me help you with that. Okay, look at this diagram. Okay, I've drawn one box, I've drawn another box, I've drawn one more box, and I'm keep on drawing boxes. So what I'm doing, one box, take it as one algorithm. Yes, Rishi Gaikwad, you are very much correct. So one box is, assume it as one algorithm. Another box, another algorithm, another box, another algorithm, third box, fourth algorithm. Okay. So just think, let's say you want to go for a surgery. Just think, okay, nobody should go for it. So let's say you are going for a surgery, and now it is very critical situation for you to undergo that, and you have to decide which hospital should I go for it. Okay, now you will not simply simply choose akkad bakkad bombay bo. You will not do that way. Okay, 1 2 3 4 5, just pay 5 5 will go. No, you'll never do that. What you will do, you will ask somebody. Okay, and who will be that somebody? You'll ask those people who have already gone through that kind of surgery. So you'll ask your relations. Okay, you'll ask your family, you'll ask your friends. Okay, you'll see online. So what you are doing, so many things you are exploring. Are you just asking one person and just directly deciding? No, even for small decisions we take help from multiple people. Okay, similar way ensemble learning says that your one algorithm may not be apt to give you the output, so you take help from more than one algorithms and run them on the same data or a same or subsets of the same data, and and look at their output and combine their output to get the final output. I believe, is this clear, right? So Saksham, I didn't get that particular word, but yes, combining multiple algorithms. Okay, they can be supervised, they can be unsupervised. Okay, combining multiple algorithms and taking output and then aggregating, combining that output together to get the final output. That is the approach of ensemble learning. Okay, so you can note down bagging, boosting. These are the techniques in, okay, bagging and boosting are the famous techniques in ensemble learning. All right, so let's move ahead and discuss next. Yes, yes. Here I have given one example. You can see this particular example. Okay, so here what is happening? You can see that we have weights. Okay, 10, 100, price is 100, weight is 20, price is 150, weight is itna, price is 200. And then we have one algorithm, decision tree, random forest, k nearest neighbor. Three algorithms are here. Okay, so we have a new input called as weight 28. Okay, so now for weight 28, it will look at all these data sets, and for 28, the value should be somewhere around 150 to 200 because it is more than 20, it is less than 30. So decision tree says 150, random forest says 150, Canon says 200. Okay, so three different outputs we have got. Okay, individually, none of them are very correct. Okay, but what we did, we basically combined them and we did a voting. Okay, so 150, 150, most of the algorithms are saying that for 28, 150 should be the price. So we have selected 150. Okay, another method we could have got is, we could have got another method, that is average method. One can be maximum voting. Okay, so 150, 150 maximum vote, we have got it. Okay, average method could be 300. Okay, 150 plus 150 plus 200. So 300, 400, 500. So 500 divide by 3. This could have been another. Okay. Hmm. So in this case, it could have been near about 180 or something. Okay, so so this is another method. Okay, with the help of average we have aggregated. So this is happening in ensemble learning. More than one machine learning model is being used, and that is helping us to coming out with the prediction. Okay, now another way is probabilistic learning. Till now, how many learning approaches we have seen? Supervised, unsupervised, and now we are coming to probabilistic method. Okay, so in case of probabilistic method, here you can see tossing a coin is the best example. We have one coin, so it can either have head or it can have tail. Total number of events we have 2, and the probability of getting head is 1 by 2, probability of getting tail is 1 by 2. Okay, probability of getting either of them is 1 by 2. Okay, but this concept becomes more interesting when basically we have let's say two coins. Okay, a set of coin. Okay, okay, two coins are there, and parallelly we are throwing them and trying to identify. So there is a concept called as conditional probability. Okay, so what is happening in conditional probability? Let's say conditional probability can put a condition. Okay, it will ask you what is the probability of getting a head given that, given that one coin always gets tail. Okay, so what we have done, we have given some condition. So if we have given some condition, what is the probability that you will go out of your home given it is raining? So already one thing is happening, and what is the probability that you will go out in that? Okay, so this is called as conditional probability. Some condition is already there, and then you need to find a probability. So the formula you can see here, probability of A such that B is already occurred. So we are trying to find probability of A, occurrence of A, but B has already happened. Okay, it is equal to probability of A intersection B divided by probability of B. Okay, understand? It is probability of A intersection B divided by probability of B. So this is the formula for conditional probability, and this conditional probability further gives birth to Bayes theorem. So Bayes theorem. So if you basically write probability of A by B and the formula, and you write probability of B by A and then the formula, and if you just equate them, then you will come out with this particular equation. Probability of A given B has already occurred, which is called as posterior. Probability of A being true given B is true. So B has already occurred, B is true, is equal to probability of B by A, okay, the opposite of it, into probability of A divided by probability of B. Okay, this is the Bayes theorem. And from this Bayes theorem itself, the Bayesian, okay, naive Bayes classifier or Bayesian networks comes into existence from this only. Okay, so for more details, we may not be able to go now. Okay, if you want mathematical details of it, okay, that separately we can discuss someday. Okay, but from here only you can see that from simple probability, then conditional probability, then Bayes theorem, and from Bayes theorem only your Bayesian networks and naive Bayes classifier actually gets created. Okay, so after probabilistic learning, then another very interesting learning is reinforcement learning. This is very interesting. So here you can see the pictures of a dog. Okay, so here we are trying to teach a dog that how to play with a ball. Okay, and we know that dog will not understand human language. It will understand something. Okay, what? It understand our actions. Okay, maybe the tone of our voice. Okay, so it doesn't understand the whole of the human language, but it understands something, the way we are, okay, dealing with the pace or the tone we keep with the voice, so all that the dog understands. But once we are starting to teach the dog may not be able to understand exactly what we want the dog to do. So in this case, what we will do, we want the dog to catch up a ball. Okay, so we throw the ball to the dog. The dog doesn't catches up, so we don't speak to the dog for 2 minutes. Another after 2 minutes, we come back and we are throwing ball to dog once again. And in this time, the dog catches up the ball, and we basically stay with the dog and we give it a chocolate. Okay, let's say chocolate cake or whatever dog likes. So what happened? Now dog knows if I will catch up the ball, I'll get a reward. This is a strategy behind reinforcement learning. I believe you got the concept how reinforcement learning works. Here basically you get some rewards or you get some penalty. If the dog is not working well, what we will do, we will not reward, or rather we will give penalty. We will not talk with the dog for some time. Okay, that's a penalty to the dog. So this is the method, okay, which happens in reinforcement learning. Okay, so here you can see that whenever a dog is picking up the ball, that time we will give some kind of rewards to the dog, maybe something to eat, maybe we will play with it. Okay, so here the dog is called as agent. Yes, somebody wants to say something. So here the dog is called as agent, and where we are,
మమ్మీ పాలు చూడు సుఖమే నీకు
can you mute
చూపించు
yourself?
చూడు నేను ఇన్ని వేసిన సరిపోతాయా బాబాయ్ ఎక్కువ
Okay, thank you. Yes, so the dog is agent, and where we are along with the dog, that is called as environment. And when we are about to throw the ball, that is one state. As soon as the dog has catched the ball, that is another stage. Sorry, state. Okay, so state is basically a particular situation. Okay, not situation, a particular yes, we can say situation where things are at particular space and position. And as soon as some action is being taken, okay, so you can see action is another terminology here. As soon as some action, I throw a ball, so throwing a ball changes the state, because earlier the state was where ball was in my hand, but now the ball is in air. That is another state. As soon as the ball reaches up the Yes, a ball is catched by the dog. That is another state. Okay, so in all the state, after performing an action, dog will be either rewarded or will be penalized. Okay, so either penalty or basically rewards the dog will get, and dog will develop one strategy by that time or policy. Okay, that what dog needs to do and how the dog needs to do. Okay, so it will develop the strategy in some time. This is how reinforcement learning actually works. Okay, so this is diagrammatic representation of the same. Okay, fine. These are some useful links here. Let us now have a look at, yes, which programming are you more comfortable with? The R programming you are more comfortable with, or Python programming you are more comfortable with? Which programming are you more comfortable with? Quickly let me know.
Sir Python.
Okay, Python you are more comfortable with. All right. Python. Okay. Yes. Hmm. So why did you choose Python?
It is having all built inbuilt functionalities and it is easy to use.
Okay, it is having inbuilt functionalities and it is easy to use. Okay, okay, fine. Hmm. Okay. Hmm. So there was a question, why should we use R rather than Python for data science from Athar? I got one question. And the question was, as a student, what kind of data science project one should build? Okay. And then certain questions were there. Instead of can we go with Python if possible? Okay. Why is data science? Wow. I believe why is data science? This question is it still there? I don't think. I don't know anything about data science. No worries. I think we have covered from the beginning. Machine learning. Okay. What is the need of data science? Okay. How to integrate Python with R? Why do you need to do so? Aman, you had a question. Can we integrate Python with R? So my question is why Aman Dubey is not here. Yeah, why do you need to do so? That is important. It helps in industries unknown about it. Scopes. Okay. Moreover, your questions are generic. Easy way to enter this field. So easy way. Don't find easy ways. Just make things easy. Okay. The way will also become easy. There are no shortcuts anywhere. So that is the answer to the question I have received. Mm, okay, fine. Yeah, so not much questions you have put. Okay, so let me answer and I'll share my screen as well. So one thing is that you can choose any R or Python. Okay, if you have a love with some language, you can go ahead and you can choose that particular language. No worries. Okay, but still, okay. Still, I will say that Python is more preferable as compared to, okay, if you talk about R. Okay, so you can see in front of you, I have opened R Studio. Okay, so you can see here, this is R Studio opened up here. Okay, so R programming language is a statistical mathematical language, no doubt. Okay, no doubt it is. Okay, but the only challenge why didn't get that much of popularity, why it was uh, yes, why it was it lagged behind. The reason is because Python has got a capability to create or to integrate with web applications. So lot of ultimate objective is to give your customer end user a benefit of whatever services you are giving to your customers. So that we can give with the help of web applications, mobile applications. And then another thing is, in case of networking, in case of scripting, Python has got upper hand than R. But at the same time, if we talk about the statistical packages, if we talk about the machine learning packages, so Python is equally good with R. And therefore, Python has a higher weightage over R. Okay, I believe this answers your question. Why Python is more being used or more preferred because it is having more options to be which can be used. Okay, fine. Some students are requesting to join, kindly admit them. So there is no waiting room here, so everybody can join in. Yeah, so there is no waiting room enabled, so everybody can join in. Yeah. Okay, let us continue. So this is our studio, and our language, if you see, it is very much similar to Python. So let me just give you, I think, yeah, this is a simple example here. You can see at this point. So you can see here that choice is equal to t. Okay, so which means that we need not to give any kind of variable data type. We need not to mention. Okay, choice is equal to t. So it will internally choose the data type for t, and because we have given it in double quotes, so it is string. Okay, if choice is equal to t, print serve t. Else, if choice is equal to coffee, print serve coffee. Else, ask is equal to read line prompt, what do you want? Okay, print paste have ask sir. Okay, so whatever the person has asked. Okay, so this is a simple example of R programming, and looking at this you can know that it is similar to Python. The only difference in Python is with all of the programming, that it has got its own indentation mechanism, which makes it different in case of writing the program. So if I execute this program, you can see below section in RStudio, this is the section where the program gets executed, and all this is basically copy paste from the top to bottom. Okay, and only the output we have is serve t. Okay, so serve t because choice is t. So if I make a choice as uh, let's say XYZ. Okay, I'm not keeping it tea or coffee. In that case, it is going to ask me what do you want, because it just did not mention anything out of tea and coffee. So if I want a sandwich, so have sandwich sir. So it is saying have sandwich sir. Okay, a simple example of R programming. Okay, so I believe Python is Jupyter Notebook must have opened. No, it is not opened. No, it is not opened. Okay. Yeah, so parallelly we can explore. Fine, let it get opened. Now I have some sorry, yeah. Yes, I have some one example, some interesting example for you. This particular example is basically creating a word cloud. Word cloud you must have seen, like normally in T-shirts, also in a lot of banners, we see that there's so many words which are printed, and many words are bigger in size, many words are horizontal, some words are vertical. Okay, so with horizontal and vertical arrangements, we have seen words are being arranged. That is called as word cloud, a cloud of words. Okay, so let us do a little experiment. Okay, and the experiment could be, um, let me ask you to share, okay, some uh, data with me. Okay, and what kind of data I would like you to share? uh, Let me send you a form, a particular form I'm sending you. Just fill in. Okay, maybe let's take it as a feedback form. Okay, so I'm sending you a form, and you can just put in your feedbacks into it. Okay, so we will create a word cloud of the feedback itself. Okay, so let me send you a link quickly. Yes, so feedback, let me name it as feedback. Okay, Hmm. So I'm just sharing with you a form, and in this particular form, you can just write something. Okay, something means it's a feedback. You can write a feedback basically. So yeah, in the chat, for that only we will do the we'll create a word cloud. Okay, we'll try to create from that. So I've sent you a form for testing purpose. Just fill it up, and by that time let us have a discussion on this particular. Okay, so this is an example of creating a word cloud. Now what will be the use of creating a word cloud? Now the practical use we will be seeing here, that you are giving some kind of feedbacks. I just request click on the link and share any kind of feedback for maybe for this session. So this will help me to understand that what are the most frequent words used by the participants while giving the feedback to me. Other thing is, whenever some political leader is giving some speech, or a social maybe leader, social worker is addressing public. So what are the top priority or topmost words that person is using? And because these people have calculated number of words in their speeches, and therefore each word is very important. So that basically gives that which topics, which words, which issues are really really matters for these people. This is something we'll get to know. Okay, so I'm just trying to see that whether you have started giving any. So I've got two responses here. So I'll just awesome, great. Yeah, it would be better if you can write some lines. Okay, learned some new terms related to data science. Thanks. Yeah. So if you will put lines, then that will help us to get more data for the program. Okay. So fill it up. Okay. I'm just creating the sheet, and I'll just copy the feedbacks and we'll give that into a text file. Yes. So let me give, maybe if you want to edit, you can edit and write a line. Edit after submit response. Yes, I'm giving edit rights, save. You can edit and write a line. Hmm. Fine. So this particular program, some libraries are required. So the commands for that is like in Python, we will see it is different. In Python, we write import, like in other programming languages also we write generally import. So here we have to write just library and the library name. Okay, so we have a TM for text mining, we have Snowball for text stemming, we have word cloud for word cloud generator, and RC color brewer. This is for creating, giving colors to the words which will be displayed. So based upon the size, it will keep on giving the different colors. Same size will have same color, different size will have different color. Okay, so these are the libraries. And text is equal to read lines file dot choose. So this whatever comments you will be giving, feedbacks you will be giving, I'll be putting it into a single file, and that file I'll be passing it into read lines method, which will store it into text. Okay, then I'll be using the libraries. Okay, I'll be using different functions from the libraries. Docs is equal to corpus vector source text. So from text, it is basically fetching the data, and we'll be able to see head docs. Okay, what data it has been able to get. Okay, then after that, here you can see two space content transformer function. So x comma pattern, here we have g sub pattern. So this basically is removing whatever white spaces or extra spaces are there, so those it is actually removing. And here also it is what it is doing, it is basically identifying slash or at the rate or slash slash or pipe symbol. Okay, so these things it is converting into simple spaces. Okay, it is converting, so you can have more number of special symbols or characters included, and you can keep on removing those things. Okay, then we also need to remove things which are called as stop words. Okay, stop words, like stop word can be anything. Okay, uh, um, maybe you want to remove a and the. Okay, so those you can remove. Those basically you want to remove numbers. Okay, maybe somewhere it is some numbers are used. So those things you can remove, and here also convert the text into lowercase. Okay, that is also important, because otherwise the program will treat two different examples, okay, two same words as two different words, just because they are in small and capital case. Hmm. And yes, after that, term document matrix. So we are trying to create a matrix. This matrix is basically giving some frequency count. Okay, it is giving frequency count of each word, and based upon that, we are passing into the word cloud function all the words we are passing here. Okay, with the help of frequency. So with the help of frequency, it will be, and maximum number of words 200, minimum frequency should be 5, random order is false, rotation dot per is 35%, colors as per the brevier. Okay, so all the options we have given here, uh, with the, how do we want to select the uh, number of words which are given in the file. Okay, and this word cloud is going to create a small cloud or a big cloud, depending upon the, okay, so depending upon the number of words we want. So maximum words we want 200, so based upon that it will be giving. So let me see, let me just, yeah, so many we have. Okay, so this much is enough. I'll just directly copy it from here. Okay, let me take it from here itself. Okay, and I'll put it into a notepad. So control C, simply let me put it into a notepad and save it as a file. So let me save them as a file, save, and desktop only, feedback. Okay, so I have saved this file on desktop. Okay, now let me go to this, let me run this. Okay, so it will ask me to select a file. Okay, yeah, it is asking me to select a file. Let me select it from desktop, and let me select it from feedback. Okay. Oh, so it has given only two, informative and session. Okay, maybe some transformation. Yeah, so here you can see. So minimum frequency was 5, and therefore it has taken only two, informative and session. So you can see here, session is occurring for 7 times, informative is occurring for 5 times, lecture for 3 times, helpful for 3 times, sir is for 3 times, data is for 2 times. Okay, so this is a term and frequency, okay, word and frequency table you can see here. Okay, and because we had given that minimum frequency should be more than 5. Okay, so this time we had little data, very less data, and therefore we have got we cannot see it as a cloud also. It doesn't seems to be very interesting. Okay, but we have got it. Informative is something, and session is something which I have received most in the feedback part. Okay, let me just quickly see if I have a file for some speech. If I have a file for some speech, I will just try to use that file. Maybe business analytics, maybe here, Trump, I think. Yeah, this is a, yeah, Trump's speech. Yeah, this is a Trump speech. I don't know for which date, but we have it now. From his speech, let us create. Yes, so here you can see, from a speech we have created a word cloud, and this word cloud is showing us that border is something he has been using most frequently in the speech. Okay, so that's something, a topic of concern, or maybe a discussion topic of discussion for Trump in that particular speech. Okay, apart from that, security, illegal, then Congress, Democrats, crisis, country, barrier, will. Okay, so these are the other words he has been using. And here we can see that, so border is 17 times, illegal is 11 times. So this shows that he is actually speaking about some border issues, about some illegal activity. Okay, this, and security. Okay, and that is actually hampering, must be hampering security. Okay, so these are the top words which actually gives us a gist of You know that you haven't read the speech, I don't remember the speech, but this particular word cloud is giving us a sense that what that speech is about. Okay, so similar way, this word cloud, you can call it as, this is called as descriptive analytics. Okay, we have analyzed EDA, okay, exploratory data analysis. We have analyzed that what is it about, what data is trying to say, and it was completely unstructured data. So this word cloud is working on unstructured data beautifully and giving us some interesting results in the form of a cloud of words, giving them different shapes. So border is the maximum size, illegal is little less size than security. So these are the topmost words being used by the by Trump on in that particular speech. Okay, now let us move ahead. Okay, let us move ahead into um, let's go and explore a bit of Python, and let's see there. Here we can see about, I told you about a priori. Okay, so let's see that only. A priori we have, yes, we have it here. So let me open it for you. So a priori, we discussed that a priori algorithm works on association. Okay, association means, you look at this. Okay, look at this data. Let me just do restart and clear output. Yeah, so here you can see, look at this, milk, onion. Okay, look at this data. So this particular is, are the items bought by one person. Okay, so how many records are you able to see here? One, this is two, this is 3, this is 4, and this is 5. So this means that there are 5 people who have bought some items from a shop. Okay, a grocery shop. And now we are actually we have intention. Here you can see. Okay, yeah, let me just do it like this. Yes. So yes, like Aman, he bought these things. Mansi, she bought these things. Okay, and we are trying to identify from all the people's invoices, that whatever they have bought, is there any kind of relationship between the items they buy. If there is a relationship, then we can keep those items together. That strategy we can apply, so that the person need not to search for it and then buy it. Rather, the person should get it immediately next to the item. Even if the person was not having intention to buy it, but because that is the combo which normally people buy, he might get an intuition, oh, let's buy this also. Okay, so that is the objective, okay, of a priori. And this is in business terms, it is called as market basket analysis. Okay, this particular algorithm is called as market basket analysis. So let me execute it. Now you can see here, data set is equal to, then this is a list data type. Okay, so yeah, you can see here, it is a list. Okay, inside one list I have put lot of list inside it. Okay, and uh, multiple lists we have inside data set. It is similar to R till now. Okay, now import pandas as PD. So in case of R, we have seen what we do. In case of R, we basically we type library, and inside library we type TM. Okay, the library name. This is how we import. But in case of Python, we directly write import pandas as PD. So pandas is the name of the library or package, and PD is the nickname or alias name for it. And then from mlextend.preprocessing import transaction encoder. Okay, so there is a package mlextend. Inside it there is a package called as pre-processing. Inside that there is another sub package, okay, which is called as transaction encoder. Okay, so a package can have sub packages also. Okay, and that we can import and we can use it as a function. So here you can see that transaction analysis, okay, transaction encoder is basically uh, is you can say initialized. TE is initialized with transaction encoder, and TE dot fit dataset dot transform dataset. So TE underscore ARY, it is going to get some transformed data. We will see that what transformation is going to happen. And DF is equal to PD dot data frame TE array columns is equal to te dot columns. Okay, so te underscore ARY is getting data converted, but we want data in data frame. Data frame is nothing but a table. Okay, take data frame as table only. Let me execute this and it will be very much clear. So what we are doing is, here we have transactions like milk, onion, nutmeg, kidney beans, eggs. Okay, this way. but we want transaction something. Milk will become a column, onion will become a column. Okay, so milk, onion, nutmeg, kidney beans, eggs, they all will become a column. And what we will do, we will be having, yeah, so here you can see the apple, corn, dill, eggs. Okay, so they all have become column, and we have total 5 transactions, 1 2 3 4 5. Okay, so those transactions are 0 1 2 3 4. Okay, 5 transactions here. So in the first transaction, do you see apple? No, we don't see apple, so apple is false here. Do you see corn? No, so corn is false here. Do you see dill? Dill is not here, you call it. Okay, do you see eggs? X is there, yes, X is here. Okay, so whatever is there, that becomes true, all else becomes false. Okay, this is how we have converted the data. This is another important thing in case of data science or machine learning, that you need to convert your data from from categorical to, okay, one thing, these were the records. From these records you have actually converted it into binary. Okay, true, false, true, false, true, false. This way you have converted them. Okay, so we either convert them into specific classes, or we try to convert the data into some quantitative values. Okay, 1 2 0. Okay, quantitative values, that is something we try to do because it is easy to handle that. Now, yes, there is a concept called as support. Okay, support means apple, how many times apple is occurring. So false, false, true, false, false. So the support for apple is very less. Okay, just understand it high level. So support for the apple is very less. Okay, because it is occurring only for one time. Now, how many times corn occurs? 2 times. So support for corn is better than apple. Then for dill it is less. For egg, true, 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 false, true. So it is very much high. But look at this kidney beans. It is all true. So the support for kidney beans is 100%. Okay, did you get it? How the support is getting calculated? So in all the transactions, everybody is buying kidney beans. That's wonderful. Okay, so kidney bean support is very high. So we are telling that minimum support, keep it 60%. Okay, at least 60% support should be there. If some transaction is happening only for once, so that is by chance. That is not a pattern. That is just by chance. But if one transaction, one item is basically included in all the transactions, so that is a pattern. That means people like okay, buying that. Okay, for example, let's say if you go to areas like for example, Bengal. Okay, so you will or if there is a Bengali community, so you will see that the market they visit, so fish is being very frequently bought by them. Okay, so they love to have fish. Okay, at the same time, if you see some, let's say, people from Chennai or Kerala. Okay, so they you will see that they are more fond of buying rice. Okay, instead of that's a pattern. That's not by chance. So minimum support we have kept here is 60%. So you can see that all the items which are having a support more than 60% is listed here. But at the same time, if you see all the items as single entity, also as a combo. Okay, so let's execute this one. Here you will be able to see. Yes, so here you can see that all the items which are having support, okay, individually. So eggs is 0.8 80%, kidney beans is 1.0 100%, 60% 60%. But all together if you see, okay, eggs, onion, kidney beans 60%. Okay, but here eggs and kidney beans, if you see, they have 80%. So this means that whenever somebody is buying eggs, that there is a high chances that person will buy kidney beans also, and vice versa. So therefore the person should keep eggs and kidney beans together. Okay, so this is how the conclusion we get from the market basket analysis. I hope the use case is clear, that how this okay, this a priori algorithm or association rules or simply market basket analysis works. Okay, how it helps us to take decisions. Is it clear so far? Is it good so far? Quickly let me know.
Yes, sir.
Okay, thank you. Okay, yeah. So fine then. So I'll yes, yes,
Yes, sir.
yes, yes,
My
ma'am.
voice is audible now.
Yes, yes, it is audible.
So I am thankful to and I express my sincere thanks to Kushal sir for organizing and this and presenting a wonderful webinar on data science with R programming. So I guess the student has, hello?
Yes, you are audible. Yes, please. Go.
Hello. So I guess the student has cleared all these doubts. Yes, students? Hello? So I request sir to, means the presentation for the today's presentation to share with our students also.
Sure,
So,
I'll do that. Yeah. Okay.
Thank you very much, sir, for your support today for our presentation in a very short span of time. And and you had covered all the topics which is there in the curriculum.
No worries. I would just like to add up something. There is an initiative which we have taken. It is yet to be launched, but because you are here, so I would like to just tell you in a minute. So we have taken an initiative. You can just have a look at it. This is IFADS. So this is a platform which like I didn't tell much about my company to you. So as I told you, I have two startups here in Pune. So this is one startup. This is Brushel Technology Private Limited. I believe the net is slow. Okay. Yeah. So we are a software firm, and at the same time we run trainings under the name Indeed Inspiring. Okay. So these two firms we have been running for past 5 years now, and with some other partners, we have some certain more partners. With all of them, we are about to launch this platform in November, coming month. Okay. This is IFADS. This is International Forum for Analytics and Data Science, with lot of activities. Website is still under construction, but still you can go and have a look at it. And for that, this is this under this we will have lot of activities. So if anybody is interested, you can, because we don't have time. So let me just tell you, you can either go to our you can mail us at members@ifads.org, so we can get connected, and or you can just ping us on facebook.com ifads.org/ifads.org. Okay, so that we can get connected. And if you have any want to do more into analytics, we can surely together do. Okay, you can be a member of the forum and you can do. All right. Thank you, ma'am, once again for giving this opportunity. And I'll share the presentation with you. Thank you.
Yes, sir. Thank you. Thank you so much, sir.
All
For
right.
for any query, the students can contact to you, and please provide your contact details also in your presentation slide, sir. Okay.
Yes. I'll do that.
Yes. Okay.
Okay. Thank you, everybody. Let's conclude here.